But Monique and the documentation team have incorporated quite a few Danpal products. So roofing, cladding, linings, windows and partition glazing, panels and so forth, I guess. But it looks like this is more about tailored on the roofing systems. Is that right, Hein?
Yeah, that's right. So we just decided, because there's so much to it, that it'll be a little bit hard to get everything across in the one presentation. So we've just decided to split it into roof systems, and then the facade systems, I believe, is booked in for 2 weeks from now. So yeah. But yeah, thank you for your time. I think we've got about half an hour booked in for this, so I'll run through it fairly quickly. I did do a little bit of a rejig of the presentation, just so that we just focus on those products that are actually listed with Easy Spec at the moment. And as Will mentioned, my name's Hein Lawrence. I'm the architectural consultant and the New South Wales branch manager. So I work quite closely with the CEO of Danpal, and our current mission is to reinvigorate and redesign our business to better suit the market and address some of the, I guess, the questions out there in terms of polycarbonate. So I'd certainly be keen to hear any questions and feedback from yourselves. All right, well, I'll just jump straight into it. So, like I said, we're focused on the roof systems for today. Let's flick through here. Basically, our roof systems are modular, pre-engineered systems that essentially click and connect. So they're incredibly easy to install. And our value proposition is really based around the fact that we offer designers and builders a way to harness and control natural light while offering superior thermal performance generally to glass. Obviously, glass being a very heavy and expensive option in terms of allowing light into buildings. Our solution comes in at a more cost-effective price point, and it is also lightweight, so a lot easier to install, a lot safer to use on site. And of course, you know, being polycarbonate, there are going to be some nuances around where it can be used and where it can't. And I guess, you know, what I'll do today is just run through all the products, and then if anybody has any questions, I'll give you a quick summary of just, you know, where in a general broad terms it can be used and where it certainly can't. So I'll just move. So, I mean, you'll see the photo there, obviously, of a stadium. We do a wide range of projects, anything from, you know, there's super large projects, which are stadiums, down through to awnings in the backyards and or pergolas of residences around Australia. So just a quick overview of the roofing range that we have listed with yourselves. We've got a couple of products. Really, there's sort of three very different solutions. One being Everbright, which is a tube system, and you'll see a little bit more detail shortly. Compact, which is a solid panel offering, and then our Danpal panels, which are the multi-cell extruded polycarbonate panels. There's a few different systems that go along with that panel to achieve, you know, various spans and aesthetics. And so we'll go through that. The three I think we've listed with yourselves at this point: our traditional system, our solar space system, and our free span system. So just jumping straight into Everbright, you'll see there from the render image, Everbright is a tubular system. So it's an extruded tube, which is 100 mil by 75 mil thick, so 100 mil wide by 75 mil thick. It's got 3 layers of polycarbonate through it, and is probably the most or the strongest polycarbonate roofing system that you'll be able to find. It's also used for walls, as you'll see in that photo just to the right. But obviously, as we mentioned, we'll cover off walls and facades in a separate presentation. What's unique about Everbright is that it doesn't use any visible or external framework or support. So it uses what we call a locking bar that sits in between each of the tubes, and that locking bar then gives it the ability to span, a certain distance, depending on how many of those locking bars we've got in the configuration. So anything from one aluminium locking bar or even none, one aluminium locking bar per 6 joins, through to 5 locking bars, aluminium locking bars per 6 joins. We stock these tubes in 12-meter lengths. They're very rigid, but can be curved. These achieve a Group 2 fire classification, and as mentioned, obviously there's for both roof and wall applications. So just a quick look at the technical properties here. You'll see the tube is obviously just interlocks, and then there's a locking bar that sits in between that ensures that the tubes are connected sufficiently to ensure that they don't disengage, and then it's simply fixed through that joining profile into the substructure at the various maximum span distances, which are in the span table to the bottom left. Just quickly, we stock this product in these four colors, and you'll see obviously each color has its own light transmission as well as SHGC values. I'm sure you're probably all familiar with SHGC, which is the solar heat gain coefficient, very common in glazing and windows. You can convert that U value, which is just below there, the thermal properties, a U value as standard, and then we've got a few options to increase the thermal performance by inserting either what we call polycool inserts into each tube, or nanogel into one or both cells. And so you'll see that U value with 2 cells of nanogel down at 0.18 is incredibly good performance. In terms of an R value, that's the equivalent of 5.5. So it's an incredibly high performance in terms of the thermal aspect. And then the span table there, so you'll see we've got what we call a locking spec, ranging from 1 through to 2.5, and what that means is 1 represents no aluminium locking bar, so all polycarbonate, and then 2.1 incorporates 1 locking bar, aluminium locking bar per 6 tube panel, and so on. And you'll see those free spans associated with that in a flat or skillion roof application. And then obviously we've got the ability to curve these, so we can get spans, as you can see there, of up to 12.24 meters. Just bear in mind that obviously the panel length is only 12 meters, so that maximum span is theoretical. And just a couple of photos so you can see what it looks like. So obviously a very clean look. Again, that photo on the left is from the Tasmania project, where it was all clear tubing. The ones that appear to be sort of opal or a little bit opalescent are actually filled with nanogel, and that was to achieve the appropriate thermal performance for that project. You can see there in that awning sense, and again the photo down the bottom is actually a covered outdoor learning area, which we'll see a lot of in schools. But you'll see it's very minimal sort of structure requirements, because obviously the panel will span up to 4.38 meters in a flat sense.
Excuse me, Hein, just a question on that. Are the panels trafficable?
They are, in terms of their ability to support the load. There is a standard AS 1539, I believe it is, or AS 1563 actually, which stipulates that any plastic or plastic-based product should be considered non-trafficable. And so what that means is, even though that our system can support a trafficable load, really what you'd need to do is actually support or place a crawl board over the panels if you were going to access it. And what that means is that crawl board would just sit over the panels and be supported by the internal structure. So it's a little bit of a technicality, but as far as it actually physically being able to support somebody standing on it, or even materials being placed on it, it is very rigid and can support loads.
How is it typically cleaned then?
So basically with an access ladder or a crawl board. So somebody would then use that to stand on. Those would be placed onto the roof. You can install harness points into the roof and then simply hose down or even wash down with soapy water.
Okay, thanks.
Yeah. So yeah, it's a little bit. What I'll do is I'll send some specific information on how we get around the trafficability issue, given that that standard just says you have to consider plastic materials to be non-trafficable. The next system we have is compact. So this is a solid polycarbonate panel. Obviously, that offers that glass-like transparency. This offers probably the highest impact resistance, given that it is a solid polycarbonate panel. If you're not familiar with it, polycarbonate will offer impact resistance up to 250 times more than glass, and about 75 times more than acrylic materials. We can achieve spans of up to 5.5 meters with this product. It entails using a structural glazing bar, or a free span bar as we call it, which you'll see on the next slide. Again, we stock these in 12-meter lengths, but we can order them longer if required. So if you've got an awning or a roof that is 15 meters long, that is certainly something that we can accommodate with a custom order. And these achieve Group 1 fire classification. And just some technical details there. So that just shows you the various spacer and glazing bar combinations. So we'll obviously be able to provide these in our typical drawing set, but essentially what happens here is you've sort of got a system, the traditional up the top, that would tie into an existing or a substructure by others, and then we've got other systems that will then allow longer spans. So the glazing bar, obviously you're getting a span of up to about 1600 millimeters. The structural glazing bar, that increases to 2400, and then with various size free span bars we can achieve up to 5.5 meters. Just some of the information there. Obviously, being a solid clear panel, the U value is quite high. It's quite similar to glass in terms of its thermal performance. So U value of 5.2. We recommend a slope of 5 degrees. The absolute minimum that we would warrant is 3 degrees on this particular product. And again, we stock this in clear grey and reflective grey colours, and each of those colours has its associated SHGC and light transmission values, which will be available in those data sheets. And I do actually have an optical and solar performance data sheet, which I can share with everybody straight away, that just lists all the various colours. We have a list of colours that we offer as from our library, essentially, But I did want to just mention that any color is possible. We will color match to a particular color if a designer chooses one. And typically they would just need to provide a hex code or a CMYK value, and we can then produce a sample to match that color before obviously mass producing the actual order. So just moving on here again, just a couple of photos to show you what that looks like. So again, you know, we've got that curved application on the left there, using a free span bar, so that minimizes any sort of other structure or purlins required. And then on the right hand side is a basically just a rain screen for a town in WA called Manjimup, which essentially the town wanted to protect their main sort of shopping district from the weather. Obviously with the clear panel, it's still going to allow a fair bit of heat through, but just gives you that you know, real clear and transparent effect. Did anybody have any questions on that particular product? Or again, with trafficability, there's a similar situation. You can support you know, the loads by placing a crawl board on top, and that'll be supported by the connectors, which hold the sheets together, and that obviously then eliminates any direct sort of traffic onto the polycarbonate material itself. Another reason you'd want to probably avoid standing on the polycarbonate directly is because you can scratch it, and so certainly, you know, we wouldn't want you know, people on, you know, dirty building sites, mud on their feet, climbing up and walking all over the roof, and then those stones in the bottom of their feet, you know, scratching and scratching the material itself anyway. So while it can support that live load, we would advise against actually stepping directly on it anyway. All good to move on. I'll go to, so Danpal, as you know, Will mentioned, that's what we were known for. Danpal was distributed in Australia by various companies before Danpal, the parent company, set up shop here locally. So about 3 or 4 years ago, Danpal, that's based in Israel, purchased 4 distributors in Australia, South Australia, New South Wales, Victoria and Queensland, and each of those then became branches of Danpal Australia. We're in New South Wales, we are the head office, and we have the majority of the stock holding, although each of those branches do have their own warehouse and hold some stock locally too. So Danpal is the multi-cell or the extruded honeycomb panel, and basically these can be fixed straight down into a substructure that is designed by others, so either rafters or rafters and purlins that are appropriately spaced in the sense of the traditional system, or we offer structural systems in solar space and free span, which will then really minimize the structural requirement of the substructure, which we'll go into a little bit more detail shortly. So the traditional system, as you can see in the bottom right hand corner, it's an extruded multi-cell product, so it doesn't offer the clarity or transparency that something like compact, the solid panel, does, but still allows light through, so it's still very translucent, anything from 80% translucency down to 0 depending on which colors are chosen. It's available 8, 10, 12 and 16 mil thick as stocked. We do also have 22 and 35 mil thick, which is available to order. And again, as I mentioned, those products are either multi-cell or honeycomb structured. And that obviously just gives that panel a lot of structural integrity by itself. You'll see the traditional system relies obviously on a substructure, so it has sort of a maximum span of 1.8 meters when using one of the aluminium connectors. And you'll see in the bottom right-hand corner there again, just the what we call a knee fastener, also called a panel retention clip, and that's what holds the panels down to the substructure. So again, we stock these panels in 12-meter lengths, but we can supply them in longer lengths if required. Probably the maximum length we can do is 34 meters. And because they're flexible, we essentially fold these panels into containers. So this product also achieves a Group 1 fire classification, which is the best that you can sort of hope for any material that is tested to AS 5637. And so the traditional system, depending on which thickness of panel and which connector is used, will achieve various spans as shown up there. And that standing seam system was actually invented by Danpal back in 1982 when they first invented the Danpal standing seam roof system. And again, because it's click and connect, it allows for a really rapid installation, very cost-effective method of providing daylighting under a roof. Again, a massive range of colours are available, each with their own sort of, SHGC values, light transmission values. And again, because the product is slightly flexible, it can be cold curved on site. There's a slide later on with some technical details on all the thermal values and cold curving radiuses for Danpal material. Just a couple of photos here, so you can see obviously the flexibility in it. On the left there, a project up in Queensland where it was used as a roof that sort of transitions into a wall on this bridge over the railway track at the station. And again, just on the right, just an example of it used in a flat roof scenario where it's supported by rafters and then just some battens below for visual interest. A couple of other photos just showing you some further examples. Again, that one down the bottom right hand side and also the top right hand side, and the aquatic centre in the bottom left, just showing you the natural flexibility and cold bending ability. So then moving on to solar space. Solar space is a structural roof system, so very minimal substructure requirements. You'll see that the structure is provided by this aluminium connector which sits above the panels, and so that means that from below it's a very seamless or flat appearance. Obviously, depending on which colours and that are selected, you will be able to see a shadow through of that connector. But again, uses the same panels as the traditional system and can offer spans of up to 6.1 meters. So essentially what happens is the connector, we've got various sizes of these. This is a streamline connector, and then we've got a slightly more square option which ranges in size from 60 mil through to, from 40 mil through to 150 mil in height, and basically that's what allows us to achieve longer spans. Because we're using the same panel there, also achieves that Group 1 fire classification. Just a couple of examples of what that looks like. So again, you can see, particularly in this curved application here, you will be able to achieve longer spans than the maximum that I mentioned before, simply because obviously as soon as you create an arch, you increase that structural capacity. And again, can be cold bent. We can actually roll form the connectors to suit various curves. And so you can see in this awning application, obviously it's just allowing the system to span from that wall through to these supports that have been provided at the end. Just a couple more photos in the next, just showing you some of the colours that are available to order. And again, just showing you that very seamless look from below. And then lastly, the free span system. So this system uses a proprietary bar with T section. We call that a free span bar. And essentially what this does is, again, it's a structural system. It provides support for these panels through the span from below. So then you have this appearance of sort of a rafter at each panel joint. And again, very little substructure requirements. This is also available in sizes from 50 mil through to 150 mil, which allows us to obtain or achieve spans of up to 9.6 meters in a flat roof scenario, and much more if curved. So the curving depends on what radius the curve is at. So certainly feel free to get in touch if there is a question about that. And again, using those same panels, Danpal panels as mentioned earlier. Just a couple of photos here showing you what that would look like. Incidentally, this was actually returned back down here with the compact solution to create this sort of screen at the end here, but we've got the Danpal running through obviously the roof here with the free span bar. Again, you can sort of clearly see here these free span bars able to span between this edge beam and the beam that's provided here and again at the other edge. This is a school project here in Sydney. This is a train station in Brisbane, I believe. Just again showing you some of the ability to create interesting curves, and architects will, as you know, come up with a fair few interesting designs. So we do have that capacity to assist and engineer some custom solutions to help them achieve sort of the visual or aesthetic that they were hoping to achieve. Again, here you can see these spans, in a curved scenario. And similarly here, this was for an aged care facility or a daycare facility, I think, where these bars have been curved, and so obviously can achieve a much further span. In this case, I think the span was around about 10 to 11 meters actually. And as I mentioned, just some information on those various options around solar space and free span. Showing you the various spans available or that can be achieved, and then down the bottom, the width of those panels versus the cold bending radius, and also the U values achieved. So we provide the standard U value here. That's the actual U value of the panel itself. And then the NFRC U value is typically what would be required to be utilized in like a Section J calculation, because that is a value that takes the whole system into effect, including all the aluminium componentry. So I think I've just about on the half hour now. So I just wanted to mention really quickly, when we use these roofing systems, there's really two sort of main considerations as to when they can be used and when they can't. If it's going to be part of the building envelope, that's when we would have to assess the type of fire resisting construction required for that building. I just want to go back to an image here to show you as an example, this aquatic center here. I'm not sure if you can actually see my cursor, but these aquatic centers here, they would have had to have been a type C construction for this to be deemed to satisfy application. If it was a type A or type B building, to use the roofing systems as part of the building envelope, a performance solution would be required, a fire performance solution. And so we're in the process of developing some of those as examples, so that we can share them with architects and fire engineers, because obviously we know there's been some changes recently, and the verification methods. and so we'll be able to release some more information on that shortly. Then in the other scenario, when you're using the roofing material as an awning or a sunshade or a canopy, it doesn't have to be non-combustible. There is a section C 1.14 of the BCA which allows materials to be combustible, but obviously there's a few things that need to be satisfied in terms of the certifier or the fire engineer, and that's where those group number classifications come into play. Obviously with Danpal being group 1 and the Everbright system being group 2 and Compact also being group 1. We also have some other tests that show that in a fire event, the panels do not produce flaming droplets, and so therefore would not render exits unusable. That's one of the requirements of the section C 1.14, which basically exempts other materials in the applications of awnings or sunshades or auxiliary items, attachments to buildings. And so typically we assess this on a case-by-case basis, but obviously as a general rule of thumb, any type C construction, Danpalon's okay to be used pretty much anywhere in the building because it's group 1, same with Compact. Everbright would have to be assessed because it's a group 2 product, so I believe it can't be used in things like fire exits or above I suppose fire isolated exits. And again, I'll provide more information because it's probably more relevant when we talk about facades, and so I'll provide a detailed explanation there. We probably find that say 60 to 70% of our work is either type C buildings or awnings or sunshades, canopies, and certainly the facade is really where it becomes a bit more, I guess, strict around external walling, as everybody knows, with the requirements for external walls to be non-combustible for type A and type B building or construction. And so that is in the deemed to satisfy context, but obviously we can assist architects and fire engineers with creating performance solutions. Did anybody have any questions around that? Because I know that it's a lot to take in. My details are here, obviously, and I'll share this with Honey afterwards so she can distribute this to everybody, and you're more than welcome to get in touch with me, and we do also have other staff in other offices interstate. But,
thanks for that, Howard. I think it would be good to cross or swap information on contacts in different regions and so forth, which Honey can chase you up, and then we can provide that as well. But okay. I got just a question before anyone else wants to jump in, but
sure.
It's pretty topical, the whole fire resistance and testing and so forth.
Yes.
A lot of our project would be type A and type B construction, and yes. I know we had a chat before about this as using Danpal products as a infill for a glazing system and so forth.
Yes.
Is there, in terms of cladding and roofing, is there typical words in our specification which we should be avoiding? Like we've got a polycarbonate and plastic cladding section, but
yes.
is that raising a red flag for private certifiers and BCA consultants, just having the word cladding and how we detail it?
Yeah, I mean, cladding always just raises the eyebrows, I guess, because it immediately invokes the idea of like the aluminium composite panel cladding, systems that really were the major fire issue. And but I guess it's just a matter of perception, because polycarbonate melts at a temperature of 165 degrees, and so when you, in the context of a building fire, when you're talking about temperatures of upwards of 600 degrees Celsius, because there is so little actual polycarbonate material in our panels, it doesn't actually contribute to the fuel load within the building, and so that is what we're basically trying to formalize at the moment. We're working with some of the fire engineers that were involved in writing the latest, or updating the latest version of the BCA, because we want to really demonstrate, that yes, the product is deemed combustible, but as soon as you say that to somebody, people think it means it's flammable, and I think that's where there's a bit of confusion, because simply, being combustible means that it is not non-combustible. So it doesn't mean that it actually burns, and we know from the fire tests that we have conducted, and also the group classifications, that our product doesn't burn. It will obviously eventually melt once the temperature passes that 165 degree Celsius mark, but in the case of glass, for instance, we know that glass explodes and melts as well at very high temperatures. The problem with glass in the context of fire is that it contains I guess that the air, or prevents air from getting in, and so when something like ours melts away, it actually provides not only egress in that, but it also it melts away, so there is no actual material to burn. So there's a bit of argument from our point of view as to whether glass should really be considered non-combustible as such, but that's not really a point for us to make. I guess for us the point really is that when, particularly with overhead glazing, we feel polycarbonate is by far the safest option, because it sort of retreats away from a heat source. And so again, because there is also no flaming droplets, there's no actual spread of flame, there's very, very little smoke produced, that it is a very safe option in terms of roofing particularly, and we feel facades as well. Obviously there's some consideration to be had around facades when you start looking at multi-story buildings. I believe that we're in the process now of we're actually just waiting, and obviously COVID's delayed a little bit, for our AS5113 test to take place, which will help us further, I guess, to develop more for facades, those performance solutions that might be required. But I guess, yes, to answer your question, I would probably be avoiding saying cladding, because these are glazing systems, so that's how we refer to them.
Okay. All right. Thank you. I think that AS5113 has got some pretty tough tests amongst
Yes.
which a lot of not even solid aluminium cladding passes, or composite aluminium. But I guess in the meantime, it's more of a performance solution rather than a deemed to satisfy.
That's right. Yeah. So really, as far as so really, I guess if I put it this way, we concentrate on type C construction for the building envelope, and then really any type of project when it comes to awnings, or sunshades and canopies and that sort of thing. So to give you an idea, I mean, you would have seen from the photos there, but we do a lot of sports halls, aquatic centres, schools, when it comes to outdoor learning areas, and even their assembly spaces. Class 9 buildings at 1 story high are a type C building, and and obviously other classes of buildings would be, up to 2 stories. I mean, there's some other classes also that at 1 story would be type C, but I'll circulate that. I might just put a slide in here before I send this over to you guys about how that, how to, I'm sure most of your consultants are aware anyway, but yeah, how to classify the type of construction required.
I think that'd be good. A little cheat sheet on types
Yes.
and so forth on which products.
Exactly, yeah. So so we've got a little matrix that can be referred to for that, and there is certain cases where certain single-story buildings might have to be upgraded to type B, and that's typically only if it is a very large volume, and that would generally be at the discretion of that certifier, or the I guess typically that's determined when that BCA report's initially done. So, but right. It's I guess it's fairly rare. It can be really very large single-story buildings. So, yeah.
Okay. I just got one more quick question. Sorry, everyone.
Sure.
In terms of, like, let's say if like a Zaha Hadid or a Frank Gehry came to you with, something like the Guggenheim Museum or something abstract and curvy.
Yes.
And they said, right, we wanted it out of Danpal or compact or something, one of the Danpal products.
Yes.
Could that be done, or is that
certainly? Yeah, definitely. I mean, there's a few ways. The one limiting factor, I think, is obviously the width of our panel. Because it is a rectangular panel, while you can curve it around things, you can't sort of curve it in that, I don't know how to explain that, but sort of imagine if you had a roof radiating out in a circle from one particular point. You can obviously cut these panels down and use various extrusions to achieve smaller sections. So I'm sort of thinking in the context of, imagine a pizza, right, where you've got pizza slices. You wouldn't really want to do that with our panels, because then you're eliminating that standing seam, and the standing seam is really what provides the benefit in terms of making the water tightness very easy. But certainly wrapping structures that I guess are various shapes, and so that certainly can be done. And I'll just have a quick look and see if I can find an example for you, because there have been some really interesting projects that have been done overseas and also here in Australia, but certainly can do. So it just depends on the actual geometry of it, but generally speaking, because the product is flexible, I would say yes is the answer.
You give it a crack.
Yeah.
All right. Any other questions for Hein from SCL?
I've got a couple.
Yeah, sure, go for it.
So with your just on your solid polycarb sheeting systems.
Yes.
Now you were saying that it's significantly stronger than, say, for instance, a glass product.
Yes. Yeah.
So how is that? Is that calculated proportionally? So, say for instance, if we say a awning that's made out of that's got glass infills,
yes.
and then, expected to be trafficable due to maintenance.
Yes.
Is using like an 18 mil heat strength and laminated glass or whatever it is.
Yes.
Does that mean, in theory, because of the significant increase in strength, that you can actually reduce the thickness so that polycarb panel can be reduced in thickness? So say instead of 18 mil, you might go maybe 10 mil.
10,
and will
yeah.
that have the same strength?
No, yeah, so that's correct. So it's really the fact that it's a flexible material, so it can withstand those impacts and live loads, and so what would take an equivalent thickness of glass, if you think of an impact force, say either a sandbag or a brick falling on something, On glass, obviously, because it's so rigid, it's prone to cracking or breaking, whereas polycarbonate would actually absorb that impact and withstand it. So as far as it's a bit different, I guess, in terms of the actual strength, or when we're talking about the ability to support a structure, because I know that you can get structural glass, for instance, and certainly, there's various forms of glass, but I guess when I was saying that, it was more in terms of its impact resistance. So particularly with overhead glazing, say if you've got an awning down the bottom of a 10-story building, and that building has balconies up it, and somebody drops something off the 10th story onto the glass below, you'd have to have something really, quite thick, probably, in terms of actual glass, laminated glass, or whatever it might be, to withstand that impact. Whereas proportionately, something like the 4mm solid compact would probably take most impacts, within reason. I suppose, if you're throwing a car off of the top of a building, it's going to be a different story. But yeah, so I mean, certainly like for like impacts, the polycarbonate is 250 times more impact resistant than glass. But I can provide you some testing and some information on that, just to give you some idea of how that might work.
Yeah. So you're relying on its tensile properties and
exactly
its ability to take point load. Okay.
Yeah, exactly right. Yeah.
Okay. The other one is for the for most of the clear type materials, or just any of them. Can it take secondary coatings? So say, for instance, quite often with the transportation projects, they might ask, clear surfaces, or things such as polycarb. It needs to have some sort of hydrophilic or some sort of self-cleaning properties. So can you also apply like a hydrophilic coating or a photocatalytic coating over the top, and will it void the warranty, and will it change its properties in terms of color and performance?
It potentially may change. If it's a third party doing that, then certainly it may have some effect. Obviously, we've got extensive chemical resistance testing that we could utilize to make an assessment as to whether we feel it might affect the polycarb. But our panels are co-extruded with a UV protection layer, and that layer is actually hydrophilic in itself. So when we recommend a pitch of 5 degrees on a roof, that's actually the pitch at which the surface tension of the water will break and the system becomes self-cleaning.
Right.
So typically at lower pitches, then obviously the water sort of hangs around a bit longer, and it can also allow dirt to collect, and if the moisture stays on there and dries, you might get sort of those I guess water stains, not necessarily permanent stains, but if you're not actually cleaning it off, you might be able to see it. But we also do offer some other coatings that we can apply to the panel. So we have what we call a high protection treatment, a HP treatment, and that is a secondary coating that's applied to the panel after it's extruded, and it's basically serves as an anti-graffiti layer, as well as improving things like scratch resistance and chemical resistance. So particularly, if you were, I guess it's often used in areas where there may be, I guess, a concern around vandalism or graffiti, or even in very, very, I guess, chemically, demanding areas in production lines, for instance, where, particularly in food and beverage, where stuff's cleaned down with various sort of chemicals, And again, as I mentioned, it will improve scratch resistance as well. So you know, if particularly on a facade, for instance, if somebody is worried about people walking up against, you know, or scratching the material, something like that will prevent that.
Okay. Are you able to send that option to Monique and
Yes.
Just
Sure.
It'll be good to know that, because
Yep.
I know durability is a big focus, especially for infrastructure projects.
Yeah,
So,
of course. Yeah, for sure.
Yeah.
Because we do. I was going to mention. I mean, you mentioned infrastructure. We obviously do a fair bit of that, particularly train stations. You know, transport interchanges, that sort of thing.
Yeah. Just one last quick question. It was the so you've got a standing seam, and then you've got your knee fasteners that go on that butt up against it, and then you friction fit your aluminium connectors.
Yes.
Now, is there? I've always wanted to ask is, do you have any issues with moisture being trapped in those small crevices and potentially have mold growth? And because it can get unsightly sometimes.
Yeah, for sure.
Especially if it's a clear or translucent system.
Yeah. So we don't. Sorry, go on. Yeah.
No, that's all right.
So we don't really experience that too much. Our that same extruded surface is antibacterial, but what you'll find is typically those, you know, mosses and things will grow on polycarbonate that hasn't been treated effectively to withstand UV. So the UV layer breaks down over time, and then obviously that enables you know, organic compounds or you know, biological organisms to grow, like moss and etc. So and that's where I would say that's the biggest difference between what we produce and, you know, any of our competitors, or even some of the stuff that you might find at a Bunnings, is the fact that we've got some accelerated age tests that will show this as well, which we can share with you guys. But essentially that you know, we would only experience a similar level of UV protection breakdown after 30 years, what essentially the stuff that you might find at Bunnings experiences after about 5 years. So it really comes down to the quality of the extruded panel, and that obviously has you know, a cost implication, and you know, typically you will find that the Danpal material is probably at the higher end in terms of price point to any other polycarbonate offering in Australia, or in fact probably the world, because simply speaking, it just costs more to produce a product that is that high quality. So yeah, so typically, I mean, and again, I'll just put a caveat on that to say that, you know, if you're doing a roof that's at very low pitch, then obviously there is a bit more I guess opportunity for that, for moss to grow and things like that, because you may find that dust collects, and that produces, you know, some organic matter for things to grow on and grow in. And so, but as far as the standing seam, I know you mentioned, you asked about that. I just wanted to just show you here. We don't find, where is my cross section? Here we go. I'll just zoom right in on that so you can see. It's going to be pixelated, unfortunately, but this break here, because we provide this air gap in here, that stops the capillary action of water drawing up, and so that's really what prevents any water from getting anywhere close to this. Obviously, if you're going to go submerge this in a pool of water, that's going to be a different story. But certainly, yeah. I mean, you know, this. I don't know if you can see my cursor, but this area here, you know, you may find debris collecting there if it is at a very, very low pitch, something like 1 or 2 degrees. And so if we don't recommend installing at such a low pitch, but if we if it is necessary, we would actually advise the installer to seal this once the installation is complete. So they would provide a bead of sealant here just to prevent anything from actually getting in underneath there. And that's purely for that reason.
No drama.
Did that answer the question? I hope.
Yeah. That's fine.
Okay, cool.
That's all I had.
No dramas. Anybody else or any other questions?
I've got one last to ask you, please.
Yes, sure.
You've been very professional throughout this entire presentation, but can you maintain your professionalism if I show you this?
Yes, go for it. Let me just find the. Yes. I don't know. I'm a Sharks fan, so.
I don't know if we can be friends.
Yeah, I'm from Durban.
I can hear that.
You're from Pretoria?
Joburg.
Joburg. Okay, yeah. I would have thought you might be a Lions fan then, but anyway.
Hell no.
I'm a Lions fan.
Okay.
Right. Sorry. Thank you very much, Han. That's been great.
No, excellent. All right. Well, I will. I'll make a quick update to the presentation. I'll send that through to Honey to send out to you guys, so you all have, and I'll include some of the interstate contacts as well within Danpal. And then, yeah, by all means, any questions or anything that we can assist with, just get in touch anytime. We're happy to help, and we'll go from there. And hopefully, I'll see you all again in 2 weeks' time for the walls and facade interiors. Stuff, because interiors is quite a big business for us too. So, thank you very much.
Thank you very much again for your time.
Great, thank you very much. That was awesome.
Thank you, Han.
Thanks, Han.
Thanks,
Thanks, Han.
Thanks, mate.
No worries. See you guys.
Thanks.